Hey, Algebra 1, Lesson 102, I'm going to record a video for you because it is fairly straightforward. We've been learning different ways to solve what we call quadratic equations, or equations with a degree of 2. When we solve these using square roots, okay, so if we have an equation, this is a quadratic equation because of that little 2, and we solve this with a square root because of the quadratic, we simply, like we have always learned how to, add a radical, which fizzles away our exponent, leaving us with not just 5, but could be technically negative 5, because isn't it true that negative 5 times itself is also positive 25? If it asked us to find the square root of a negative, like this, we would say that there is no real number solution because there is nothing times itself that will equal negative 16. No real solution. Okay. Example 2 says x squared plus 3 is 52. This works out great because we get x by itself beginning with an inverse of negative 3. Well, that gives us the beautiful perfect square of 49, right? So what do you think we're going to do? Bingo. So we end up with x is, don't forget the plus or minus. I might mark you wrong if you do. Let's clear away a little bit, do 2 or 3 more. If I had 4x squared minus 100 is 0. At first you think 0, this is going to be a problem, but of course not. We just add the inverse, okay, which effectively gets rid of the 100 on one side, gives us a beautiful situation on the right. What do I do next? Divide by the coefficient. Same on both sides. Answer is plus or minus 5, right? Numbers that aren't perfect squares have irrational roots. They can be expressed in square root form. So if you end up with something that doesn't come out, you can just leave it, right? Or you can approximate an answer using a calculator. So you type in the square root button, type in 79, write that decimal. And the book does seem to prefer to show their answers calculated to decimal form anyway, instead of leaving it like this. I don't know if it'll stay consistent that way, but as you can see in the examples, they seem to be doing that, and in the lesson practice they will as well. So when you get to lesson practice E, for example, and we have x squared being something ugly like 72, okay, the process is fairly straightforward. We're going to square root everything, but then what do we put for an answer? Instead of pulling out the different square roots that we can do, like 4 times 3 times 2 is what I think this would be. I think it would be 12 square root of 2. Instead of that, they just, actually no, that's not quite exactly right. But either way, they just take the square root. Square root of 72. Nope, that's divided by 2. Let's see. Might be able to get it on here. I don't have a way to show a calculator any other way. Yep, I can do it here. Square root of 72 comes out to 8.485 and so on. So they show the answer as 8.485 plus or minus, right? plus or minus 8 and 485 thousandths, and they stop there. So that's the way they do it. They don't bother with, like they show in example 3, the first one with the x squared equals 40. Although this is good practice, pulling out 2, 2, 5, and 2. So you pull out the square. Oops. They don't actually show that in any of the answers. Example 4, Malik covered a cube with exactly 864 square inches of self-stick vinyl. What's the side length of the cube? Use the formula to find the surface area of a cube. Use this formula to find surface area of a cube. Substitute 864, they said, was the surface area. Divide by 6 comes to 144. Perfect, right? Now, would we say plus or minus in this case? Normally we would, but because we know it's a real-world situation, it can't be negative. So it's just 12. We could check by putting it in, and it'll work out. The longest possible side length of the cube is 12 inches. Okay, so this gives us surface area of a cube if you ever need it. It's a good formula. Okay, why don't you try lesson practice B through G, please?